experiment with a hopper popper. As you know, a hopper popper is like a half of a ball, and when you invert it and let it drop on something hard, it pops up, usually. Anyway, I'm going to put energy into it, and I'm going to launch 3 different balls, and we're going to see how high they go. We're going to start with this yellow, orange, red ball, which is only 7.9 grams. And Charlie here, my grandson, is going to mark. We're going to do 3 trials with this ball.
With
ready,
the
All right, you ready, Charlie? We're going to see how high it goes. Question is, which ball is going to go the highest, and how are they going to compare? You ready? Were you able to see it, Charlie? Yeah. Okay, that's the first trial. We're going to do 3 for each.
That's when about the same space, except it went like.
Well, how high did it get to with the highest?
I don't know.
All right, let's do that one again. Let's just repeat that trial. Are you ready?
Yes. Huh.
Could you tell? If you couldn't tell, we could do it again.
Went a little bit, I think. Like
all right,
this.
about there. Okay, you ready, Charlie?
Yes.
Could you tell?
I think it went about.
Okay.
Here.
Okay, that's the one that's 7.9 grams. This one's 12.1 grams. It's again a different color pen. Let's use the yellow pen so we'll
okay.
be able to tell the difference. We won't get them mixed up. You ready, Charlie?
Yes.
Here we go. Here's the first. Did it go as high?
No.
Okay, it's heavier. It didn't go as high. That's as you would expect. Are you ready, Charlie? Move a little bit. You ready?
Yes.
It was hard to tell. Could you tell?
Yeah, I think I do.
All right, here's the third. Watch, Charlie. Are you watching?
Yes.
Oh, very reproducible on this wall. All right, and finally we're going to...
It seems to be going up like this and this and this.
Now we're going to look at the glass ball, which is 20.7 grams. It's the heaviest.
Here.
All right, get the black. Okay, you ready? Okay, here we go, Charlie. Here we go.
Okay.
Looks like about here.
Yeah, so it went.
You could probably get off your
Wait,
stool.
no, kind of.
All right. You think it's about there?
Yes.
All right.
Okay, so
just keep out of the way.
I think it went like there.
All right, all right. Here, let's do the second one. We can move this out of the way now.
Okay.
Okay, here we go. Oh, can you tell? About there.
That's there.
Now, here's the last one.
Okay. There.
About there.
About there.
Okay, so everybody.
They're all on different pages. This one's the 4th page. This one's the 2nd. This one's the 3rd and 4th.
Okay.
The 5th and 6th didn't have any.
All right. Now, just to show you that it does depend on the mass, we're going to launch a ping pong ball. We're not going to measure it, but it is just to show you. The ping pong ball only weighs 2.2 grams. Watch how high this goes. You won't be able to see it because it's going to hit the ceiling. Okay.
It didn't hit the ceiling, but it's too high up for them to see.
Okay. So now what we're going to do, after we're going to turn the video off, we're going to measure and get the average of this one, the average of this one, and the average of that one, and see if it's in inverse proportion to the mass. Okay? So thank you for part 1, and we'll come back on part 2. Hello again, everyone. As you can see here, we have the spreadsheet results, and we measured the heights that the 3 balls went up in inches to the nearest 1/10 of an inch. And so I got these 3 values. And now I'm going to convert them to centimeters. And to do that, I simply say equals 2.54 times the inches. Okay, let me do it again. I didn't put equals. Equals 2.54 times the inches. Okay? I didn't do it. Let me do it again. I said 254. 2.54 times the inches. I didn't put the equal sign in. All right? Equals 2.54 times the inches. All right, now I can copy these things because they're in the same order, so I can copy them this way, and I can copy them this way. Oops. Okay, now to get the average, I'm going to just take equals AVG, and it's these three. Let me try it again. AVG, the average of these three numbers. I must have. Okay, I guess it's all right. Okay, now these numbers have too many significant figures, so I'm going to just bring them down to that many places I think is appropriate. Okay, now the question is, the lighter ball went up the highest, the medium ball went up the middle amount, and the heaviest ball went out the least. Now, the energy, the formula for the energy is that the potential energy should equal the mass times the gravitational acceleration times the height. And it should be the same for all three balls because they're getting the same amount of energy from the hopper popper. Now that doesn't mean it will be the same. All right, that doesn't mean it will be the same. There's errors. So what I'd like to do is take the mass times the height. G is the same. As a matter of fact, G is 9.8, but actually I'd have to convert it to meters. Let me just take the mass times the height and see if it's a constant. Okay, so I'm going to copy this, paste it, and then I'm going to put mass times height. By the way, this is the height here. Okay, so we're going to take, this is equal to this times this. All right, and now if we copy it, we'll get the other two. Now, don't be upset if they're not exactly the same. They're not going to be. There's experimental error, but they're in the same ballpark. Let's just reduce the number of figures here a little bit. It's not exactly the same, all right? But it illustrates the point that the lighter ball, because it's lighter, can go higher because the formula is mgh. They all have the same energy. So if m is low, then h has to be high. And if m is high, then h has to be low. We do see that qualitatively, but it doesn't form an exact constant, as you can see here. And that might have something to do with well, it could be that the heavier the ball is, it might be gaining more energy from the hopper popper because it's sitting heavier in the hopper popper. It's heavier and it's weighting down the hopper popper, so it's maybe making better contact with the hopper popper and getting a little more energy. That's my conjecture. It's only a conjecture or a hypothesis. But roughly speaking, The higher the mass, the lower the weight. Okay, so thank you for your attention. I hope you enjoyed this presentation.